Hello my fellow developers. You might be wondering how hard is it to create an AI-powered SQL agent that takes our questions in plain English and then executes a SQL request over a database producing results that we were asking for. This task is very easy to accomplish these days, my friend. Today, we will use LangChain to build a simple SQL agent. The agent will take our questions in plain English, then it will use an LLM to produce a SQL request using the dialect of your underlying SQL database. Then this request is going to be executed over the database, and once the database returns the result, we will again use the same LLM to produce an answer in the format that is needed for you or for your application. Alright, sounds easy. Let's do a deep dive. To make things fast and simple, we are going to use a Jupyter Notebook. You will find the link to this notebook in the description to this video. That's why right now enjoy the video, but then make sure to reproduce all the steps on your end. Prerequisites. You need to have Docker and Python, and our LLM for today is going to be OpenAI. That's why make sure that you have an OpenAI API key. First step, we need to set up our environment. We are going to install a few libraries that are necessary for the SQL agent. The agent executes requests over a SQL database. That's why we are going to use PsychoBG2 for the database connectivity. And then we will install a few LangChain specific libraries. Let's click Start. And the environment is ready within a few seconds. Step number 2, we need to select a database. I'm going to use Postgres, but feel free to use your favorite SQL database. I'm starting Postgres in Docker, and while the container is being bootstrapped, let's go to the Docker Compose file to see how it looks. I'm putting the latest image of Postgres and then starting the database as a container. That's it. Going back to the Jupyter Notebook, you can see that, the container and the database are up and running. When you start Postgres for the very first time, you need to wait while the database initializes itself. That's why we will connect to this container, and then we use the PG-is-ready tool to make sure that the database is ready for the application requests. Once we pass this test, we will preload a sample dataset from our host operating system to our database container. And once this happens, we will connect to the container and use PSQL tool to load our schema and data into the database. Let's click Start. And while this is happening, let me go and show you the schema. That's a shoe store. It has products, users, purchases, and product inventories. What's interesting is that we are creating a special role for our SQL agent. This role will have only one privilege. You will be able to select only on the tables from your specific database or from your specific schema. And why is it important? We want to make sure that SQL agent only reads data from our database and doesn't update anything. In real-world production applications, make sure that this access is as granular as possible. You can give access to a predefined list of tables, and you can even allow access only to specific rows or even columns. It's up to you, right? Going back to the notebook, all the tables were created and we loaded our sample database. Final configuration step, my friend. Our SQL agent is going to use OpenAI GPT model as an LLM. You need to initialize this OpenAI key variable. You can pass your OpenAI key as an environment variable or just run this code snippet and pass your key in this prompt. That's what I'm doing. So the key was set, and now the time has come to work with our agent. First thing, I want to prepare a special function. That function will define and clarify the role for our agent. Think about this agent prompt as a system message where you are telling your agent what it expects to do. For instance, I'm telling that you are going to query Postgres or any other Postgres compatible database, and then I'm explaining a little bit more about the dataset. You don't need to explain the entire dataset. LangChain knows how to pull that metadata and information from Postgres, MySQL, or Oracle. However, just give some hints if you think that those hints will be helpful. After that, we are going to pass the input text, and the input text is our user prompt. When we will be asking, all right, I want to buy a special type of shoes, and this prompt will be inserted in here. And in the end, you're telling, answer like a human would. We will take this result and we would ask the agent to respond in a human way using the plain English. Let's execute this snippet. Everything is ready. And we've got to an implementation of our SQL agent. And take a look, it fits into our screen. It's so small and yet simple. First, we are importing required modules that we installed with pip before. And after that, we are creating an OpenAI agent. We need to pass this OpenAI key, and then we define a few parameters, how we want the model to behave. For instance, we set temperature to 0 because I want the model to be deterministic. I don't want it to be creative. Just do what you are asked for. The next step is we need to initialize a SQL database that will be used for our agent. Again, we are using PsychoPG2 here. And that's the username. You remember we created that read-only SQL agent user that can only read data from a specific set of tables. And this is located in Postgres. And here is, we are passing to the SQL database agent information about the tables that the agent is supposed to query. Finally, we are assembling this LLM chain. We are assembling this LangChain. First, we need to pass our LLM, OpenAI, then we are passing our underlying database, and we are also fine-tuning the behavior of this SQL agent chain. As an example, I want the agent to produce verbose results so that we all can see how the execution of user prompts looks like in real life. Let's click start, and we are good to go. We've got the green light. And here is the fun part, the actual code snippet that takes user prompt, and then you will execute this prepare agent prompt method that defines this behavior for the agent. Once we get this final prompt, we will invoke our database chain. We will get the result, and then we will print this result. That's it. It's that simple. How about we use a few requests from here? For instance, what are the most popular products? I'm copying this one, starting this code snippet, and I need to pass my question in here. And then that's the verbose mode. You can see what's happening. We are entering this chain, and that's our system prompt. You can see that that's the request that we passed. That was the SQL request generated by LLM. We executed, we've got this response. Then we responded as humans would. The most popular products are efficient jogger, portable cloud, portable runner, etc. Wonderful. How about we test another request? Which one do you like? For instance, find me shoes that are in stock and available in size 15. This one is harder, right? But not for our SQL agent. Clicking start, passing this prompt, entering the chain. The agent generated this SQL request. And that's the result, and that's the answer. The shoes are in stock and available in size 15s are portable jogger, ergonomic jogger, etc. and a few others. Sounds wonderful. How about we change the output format of this agent? Because right now it answers like a human would, but assume that your application wants to get back a JSON. Let's do this. As an example, I'm saying that answer needs to be in the format of a JSON object, and this JSON object needs to have the query with the SQL query and query response as a JSON array with the result. I need to execute this prepare agent prompt method one more time so that it's updated for my Jupyter Notebook environment. And then let's speak exactly the same question that we have just asked about the shoes that are available in sizes 15th, and execute our chain. We are passing this result. We are entering the chain. That's the SQL request, and that's our answer. Look at this. So right now we have this query, that same query that was produced. If you scroll here, that's our query response, and this response is in the JSON format. The name of the shoes, the price, the color, width, other parameters, and then it's repeated for other products from the catalog. Job done, my friend. How do you like this, my friend? Isn't it cool? It literally took us a few minutes to build a powerful SQL agent that takes our questions in plain English and executes requests over a SQL database, producing the results that you're asking for. Now, don't waste a minute. Go and find a link to this Jupyter Notebook in the description to this video and reproduce all the steps on your end. And have fun mastering databases, my friend. Bye bye now.